Hello again, algebra students, and welcome to the 1.2 notes. Today's lesson is on solving multi-step equations. We'll be looking at how you can use multi-step equations to solve real-life problems. And the learning target for today is I can solve multi-step equations using inverse operations. So, some vocab for you. First, solving multi-step equations. This includes simplifying each side of the equation if needed. This also includes using inverse operations to isolate the variable. If you forget what inverse operations are, look back to the 1.1 notes. We defined it quite nicely there. Those are operations that undo each other, like addition and subtraction, or multiplication and division. The goal of solving multi-step equations is to get the variable alone. Another strategy I've found helpful to solving multi-step equations is to think of GEMDAs, the order of operations. When we solve for a variable, we're actually going to do GEMDAs backwards. So we're going to start by undoing addition and subtraction, then we're going to undo any multiplication or division, then exponents, then grouping symbols. So GEMDAs backwards. And then the last vocab term is like terms. Like terms are terms that have the same variable raised to the same power. So 3x and 5x are like terms, but 3x is not a like term with just 7 because they do not have the same variable. It is also not a like term with 3a because a and x are different variables. It's also not a like term with 3x squared because they are not raised to the same exponent. So this bottom equation, we can't simplify at all. Versus the top one, we could simplify. 3x plus 5x is 8x, and we will learn how to do that as we go along. And again, you can download the 1.2 notes PDF from Canvas and follow along in Notability. Otherwise, you can write the notes in your notebook. All right, so example 1 is solving two-step equations. So part A, I have 2.5x minus 13 equals 2. Remember, the goal is to get the variable by itself. We're also going to do GEMDAs backwards. So I'm going to start with any addition or subtraction. I see a subtraction here, minus 13. To get rid of that, I'm going to add 13 to both sides. So once I add 13 to the left, it cancels out. So I just have 2.5x, and then when I add 13 to the right, 2 plus 13 is 15. So now I see some multiplication. I'm going to use the inverse of multiplication, which is division. So I'm going to divide by 2.5. Because I did that to the left, I also have to do that to the right. 2.5s are going to cancel out, and I'm left with x equals 15 divided by 2.5, which is 6. And that's my answer. You could plug this in to check 2.5 times 6 is 15 minus 13 is 2. All right, part B, I have 4u divided by 3 equals negative 8. All right, the first thing I'm going to undo is that divided by 3. To undo divided by 3, I need to multiply by 3 because division and multiplication are inverse operations. 3's are going to cancel out, so I'm left with 4u equals negative 8 times 3, which is negative 24. And now I need to get rid of that 4, so divide by 4, and I have u equals negative 6. If I plug that in, 4 times negative 6 is negative 24, divided by 3 is negative 8. All right, so example 2, solve the equation by combining like terms. Like terms was part of our vocab for today. A like term is a term with the same variable raised to the same power. In this specific equation, I see the like terms negative 2x and negative 10x. So I'm going to do a little side note here. Negative 2x minus 10x. Now, it might be helpful to think of the distributive property. If I took x out of both of those terms, I would have negative 2 minus 10. And we know that negative 2 minus 10 is negative 12. So that's negative 12x. Another way to think of it is if I have negative 2 x's and I take away 10 more x's, I'm left with negative 12x. All right, so side note, now I know negative 2x minus 10x is negative 12x. So I'm going to simplify that equation first, and I'm going to rewrite it as negative 12x plus 12 equals 18. Notice I just combined the like terms and then substituted that negative 12x for negative 2x minus 10x. All right, so now I have a two-step equation, which is just like we solved in example 1. So first thing I'm going to do is get rid of any addition or subtraction. I see plus 12. I'm going to undo that by subtracting 12 from both sides. The 12s cancel out on the left. So I have negative 12x equals 18 minus 12, which is 6. Now, some of you in younger grades might have been taught to draw a line down at the equal sign. I personally don't do that, but if that helps you to stay organized, feel free to do that. That also is helpful in reminding you to do the same thing to both sides. So if it's helpful for you to draw a line down from the equal sign, go for it. All right, so now I have negative 12x equals 6. That is multiplication. Negative 12 is multiplying by x. So I'm going to use the inverse and divide by negative 12. The 12s are going to cancel out on the left. I have x equals negative 1/2. You might also write this as negative 0.5. Example 3 is problem solving. Use the table to find the number of miles, x, you need to bike on Friday so that the mean number of miles biked per day is 5. Here's a vocab word that's not even part of our vocab. So, think back to like 4th or 5th grade, and what does mean mean? The mean is the average, so that's if we add all of these numbers up and divide by how many there are. Well, there are 5 days, so we're going to find the sum of those 5 numbers, and then we're going to divide by 5. So I'm going to set this up in an equation. I have 3.5 plus 5.5 plus 0 plus 5 plus x, because we don't know what he biked on Friday yet, divided by 5. All right, so now I'm going to solve for x. And the first thing that you might notice when you're looking at this equation is that, wow, that's a lot of addition in the numerator. So we're going to simplify the numerator. I'm going to add 3.5 plus 5.5 plus 0 plus 5, which is 14. So now I have 14 plus x divided by 5. And we want the mean to be 5. So I want this to be equal to 5. I should have wrote that in the top one too. All right, so now we can start solving, and I cannot undo the addition first because right now it's almost like there's a parentheses around this because they're in the numerator together. So I'm going to group those with a grouping symbol, and I undo that last. So the first thing I'm going to do is undo this division by multiplying by 5, which I have to do to both sides. So then these 5's cancel out. I have 14 plus x equals 5 times 5, which is 25. And then I can subtract 14, and I have x equals 11. So how many miles did he have to bike on Friday? So the mean is 5 miles per day. He has to bike 11 miles. That's what he gets for skipping Wednesday. All right, example 4 says solve each multi-step equation. Notice there's a little side note to part A reminding us what the distributive property is. You should have learned this back in 3rd or 4th grade and reviewed it a little bit in 6th, but it's going to be really important in algebra again. So, reminder, if there is a number outside of parentheses with addition or subtraction going on in between or inside the parentheses between terms, you can distribute that outside term to both. So if I have A times B plus C in parentheses, it's equal to AB plus, this should be AC. AC. All right, so part A, I'm going to distribute that 2. 2 times 1 is 2. 2 times negative x is negative 2x. Plus 3 equals negative 8. All right, and now I can start solving for x. I do see some like terms on the left side. 2 and 3 are like terms, and 2 plus 3 is 5. So I'm going to combine those, and I have 5 minus 2x equals negative 8. All right, now I'm going to do GEMDAs backwards. So addition and subtraction. This, I could think of this as plus negative 2x. I'm going to do that for now so then I can divide by negative 2 later. To undo that addition, I'm going to subtract 5. These cancel out. So I have negative 2x equals negative 8 minus 5, which is negative 13. And now I undo the multiplication, so I'm going to divide by negative 2. The negative 2's cancel out. And I'm left with x equals negative 13 divided by negative 2. Those negatives are going to cancel, so it's a positive answer. That positive answer is going to be 6.5, or 13 halves, or 6 1/2. However you write that is just fine. They are all equivalent answers. All right, so next part, we're going to distribute that 4. So I have 3. Negative 4 times 2d is negative 8d. And negative 4 times negative 3 is positive 12. So I have 3 minus 8d plus 12 equals negative 1. Now I see some like terms again. I see 3 and I see 12. I'm going to combine those. 3 plus 12 is 15. So I have 15 minus 8d equals negative 1. Now just like I did in the last one, I'm going to think of this as a plus negative 8d, and now we're going to solve it. So I can undo that addition by subtracting 15 from both sides. The 15's on the left cancel out. So now I have negative 8d equals negative 1 minus 15. It's going to be negative 16. Now I undo the multiplication by dividing by negative 8. I have to do it to both sides. So the negative 8's cancel out on the left. I'm left with d equals negative 16 divided by negative 8. Negative divided by a negative is a positive. 16 divided by 8 is 2. So d equals positive 2. And now we could check this. I'll do it in a different color so you can see. We'll check it by plugging 2 into the original equation. So I have 3 minus 4, 2 times 2 minus 3 equals negative 1. And let's see. If we're starting with order of operations, we're going to start here, 2 times 2. So 3 minus 4 times 4 minus 3 equals negative 1. Then we start at this part, the parentheses. 4 minus 3 is 1. So 3 minus 4 times 1 equals negative 1. Then I do the multiplication. 4 times 1 is just 4. And 3 minus 4 is, yes, negative 1. So we're good. D equals 2. Example 5 has some problem solving for us. So you have 96 feet of fencing to enclose a rectangular pen for your dog. To provide sufficient running space for your dog to exercise, the pen should be 3 times as long as it is wide. So find the dimensions of the pen. First, I'm going to make a sketch of the pen. To provide sufficient space, it should be 3 times as long as wide. So this is W, this is L, and L should equal 3W. Now you have 96 feet of fencing. And this sounds like fencing is the perimeter. So perimeter equals 2 times the length plus 2 times the width. The perimeter needs to equal 96. I know L equals 3W, so I'm just going to substitute this 3W in for this L. So now I have 2 times 3W plus 2W. All right, and now I simplify and solve for W. So 2 times 3 is 6. First thing we're going to do is simplify this part to get 6W. So now I have 96 equals 6W plus 2W. Now I can combine like terms. So 96 equals 8W because 6W plus 2W equals 8W. And now I use the inverse operation of multiplication to divide by 8. And 96 divided by 8 is 12. So I have W equals 12. All right, summary questions for you. How do you solve a two-step equation? Well, we use GEMDAs backwards. And we use GEMDAs backwards. We simplify. We get the variable by itself, and we're using inverse operations. So how do you solve an equation with like terms? Well, like terms were one of our vocab words. You can combine like terms if the term has the same variable raised to the same exponent. And how do you solve a multi-step equation? Well, same thing, GEMDAs backwards. We want to get the variable by itself. And how can you use multi-step equations to solve real-life problems? Well, we saw two examples. We saw the example of fencing and perimeter, and then we saw the example of miles biked and the average. All right, and make sure you check Canvas to see if you need to submit these notes or what else is on the assignment for today.